Hi, this is Daniel Slutsky of the Clojure group. We are the group that creates a Clojure toolkit for data and science. And today, in this tutorial, we will look into the Nodge project created by the Clojure. Nodge is a collection of tools and libraries for data analysis and scientific computing in Clojure. It is the core of the Clojure toolkit for data science. What we will do is use Nodge for a little data analysis project. We will begin with the raw data and we'll end with a little published report of visual analysis. The data we will be looking into will be the data of the Clojure calendar feed. Probably you know about it. You can follow Clojure events with the calendar feed created by our friend Gert. And the data of these events is these data that they tell the story of the progress of our community in a way. And we'll try to tell this story in a visual way, while little visualization will create. Let us begin. You see, the Nodge project has this list of underlying libraries for the common needs of data analysis. And we will use a few of them in this analysis. We will create a small Clojure project where we can use them. So as usual, we begin with a depths.eden file. And our only dependency will be Nodge because it already brings all the other things. So here you can see the Nodge page. It's the Clojure's website. And sorry, we will add the depths.eden dependency. Great. So now we can start the REPL. I'm using Emacs with Cider, and we will create other tutorials for other programming environments. And as you know a little bit of Clojure. So here I'm using Emacs Cider jack-in. This command will start a Clojure REPL, as you probably know. And we will create some code. I'm creating a notebooks directory, which is the common practice when we create those data analysis notebooks. And in the notebooks directory, I'm creating one file. It is commonly named index.clj, which is a common practice when you have only one notebook in a way. And this way, when you publish your report, this will be turned into the index.html file. And let's check whether we can evaluate. Yeah, it evaluates. It is empty. Great. So this namespace is also our notebook. That's our approach. So we can add comments like, Nodge getting Nodge version 2 getting started, and maybe add some texts. In this tutorial, we analyze the data of the Clojure. Feed. We can add the link to the feed to this page that our friend Gert has created. And yeah, so this way we have our story being told. One part of the Nodge collection of libraries is Clay, which is one way to visualize data in Clojure and also to make notebooks. So, when you look into the Clay project, you'll see that it has, recommended setup for various uh, Clojure editors and IDEs. We will use the setup for Emacs. So here you see I have an Emacs package called Clay installed, and I can have these Clay commands. For example, we have Clay make namespace HTML that will turn this namespace into an HTML page. So I call it, and for the first time, it takes a little moment for Clay to load and open a browser tab with our namespace rendered as a notebook. Another thing we can do is, we can compute some things and, do that again. I have a key binding for this, so I call the key binding, it re-rendered again. And you can go, not the whole story, but also just the result of visualizing one form. So you see, you can do Clay make last s expression. In this way, you just get the last expression, the last Clojure form visualized, and we'll visualize things in different ways. Right. So I'm using key bindings for this, which are set up in my Emacs. Of course, you can do it in your Emacs as well. Let us begin by bringing the data. So you see here, the Clojure calendar feed has this ICS file. We can copy the address of this file, and it is this URL, and behind it there is a file, a gradually updating file of Clojure events. Let us read it and maybe print. And you see, when you read this file and print it, you have this string representation in ICS format of Clojure events. We'll, for reuse, we'll keep it in a var. Let us call it feed string, and we'll use def once. So, next time we evaluate this, it will not need to read again. Now, let us look inside. Yeah, maybe let us add some nodes to our notebook. This is the setup. Maybe here we have like data reading, data exploration, initial exploration. So, what is that? This string. So we may wish to visualize it in our notebook. So to do that, we'll use another component of the Nodge collection, and that is kindly. Kindly is a standard way to request data visualizations of different kinds. And it is supported by the Clay tool, but also by other tools. And that's the way we'll represent our requests in this session. So here we are, calling for kindly. Oh, it is raining a little bit. I hope we don't get too much wet. Yeah. So, right. So we really require the kind space, and here, this way, it's example, our data with some kind. So, for example, we can ask to visualize it as if it were code. So we come back to the Clay view, and now it is visualized as code with some highlighting. Maybe that's convenient. And we can keep going and maybe create some pickup, which is the Clojure way to represent HTML as data, and we can wrap it with a div with some styling, maybe something like that, and overflow. Okay. All right, so now it should be scrollable, a scrollable box. And again, we can render the whole notebook and see the whole story being told. Right. So yeah, so that's our data. And let's begin parsing this data so we can work and analyze it. So um, data parsing. Let us begin. So when you look into this feed string, you see those marks of the end and beginning of an event. We'll use those marks to split the string into events, if it makes sense, right? So we'll use the Clojure string namespace and split the string by this mark, an end and a beginning, and a new line between them. What happens when we do that? It is convenient to look into it in the Emacs editor, and so I'll use cider pprint last preprint eval last expression. This way I got this data structure in this buffer, and I wrap the line. So you see we did split our file into many events, and each of these is just a string representation of one event. So let us map over events strings. Each of these event strings is composed of a few lines, so we will split it, right? If string split lines, and again I call this way to pretty print the result, and you see now we got them getting some shape of events as data structures. Of course, in Clojure, we like to turn these things into sequences of maps, right? So we want a sequence of maps representing events. So let us map over these. So in each case, in each of these cases, we have the lines of an event. So we will handle each event line. What we do with the event line is, we try to recognize those keys or identifiers, right? So we can, for example, let the key be whatever we find or not find as URL, as the URL pattern in our event line. And, let us for now just print the key. So now you see some of the lines do not recognize as URL, but, one for each event does recognize as URL. So let us turn this key into, a keyword as we usually like in Clojure. So we can take this key and maybe clean it a little bit. We replace the colon with an empty string, and we maybe turn it into lowercase and to a keyword. So now we have this. Oh, right, something is wrong, of course, because it is null sometimes. Not always we find this. So we should say when, right? Not always we find a URL in our line. So now sometimes they're nil. Sometimes they are the URL keywords. But we also wish the value for each of these keys. The value will be the URL string. So we create this pair of a key and a value, a key value pair. And the value will just be the event line with the key removed. So we replace K with the empty string. And now it is starting to get some better shape. And let us do that not only for URL, but also for summary and the time stuff. So summary, the rain is getting stronger. I hope we can continue. Right, so we do it again, and we get these passed. And now let us, put them into a map, as we typically like in Clojure. Right. So now you see, this is the moment where a Clojure person is starting to be a little bit happy because, you know, these nested data structures, maps, inside sequences, and so on, they are something we really like to process in Clojure. So let us keep going. One of the libraries we'll be using from the Nodge collection is tech.ml.dataset. It is a high-performance library for dataset structures, which are, in a way, tables or data frames, as they call them. And typically, we use it from within tablecloth, which is a wrapper, friendly and consistent wrapper of tech.ml dataset. And you may like the tablecloth documentation, which offers, those different ways to create and process tables. And at the moment, we'll just, require the tablecloth namespace, main API namespace. And it takes a moment to require. It is a little big with a few things behind it. And now we can use it to create a map, to create a dataset structure. Right, now we have a table structure. I think I may need to stop for a moment because the rain is becoming big. I'll try to move to a different location and continue over there. So see you soon, probably. Hello again. Hi. Earlier I thought it would be a good idea to sit in the park, but it was raining, so now I'm at the office and we will continue. Right, so we were just at that moment where we created a tech.ml dataset, right? This data structure that prints as a table and has a certain clever data representation behind it. And now we can work with that. This is maybe not so familiar to all Clojure people, but the ergonomics of these data structures can be quite nice and efficient. And one more thing we may see is that, if we go back to the clay view, we can view this data structure. And yeah, I need to refresh the browser page because I was on a break. Right, so you see it is, displayed as a data set, as a table, HTML table. And we can, add, set the data set name to be like Clojure feed, and then it should be displayed nicely, right? And one thing you may notice is that we have those date strings, and we may pass them as actual date time values. Let us do that. Tech.ml dataset, when you use this dataset function to create a dataset, it allows you through the tech.ml dataset infrastructure to specify some parsing, specify a parser function. And we may specify it for each of the fields we have. So here we use the dt start key for the date time start. And we, need to specify the type of it. That will be local date time in our case. You may find these things in the tech.ml dataset documentation. And you may also specify, the actual date time pattern, which will be in our case, y for year, and then month and day, and then this t character, and hour, minute, second, z. Let us try again. Great, now it looks different. Now it is an actual date time object. Let us explore this, to kind of actually get convinced that we got it right. So, maybe like, let's call it exploring the dataset. So to do that, let us give it a name. Let us call it the feed dataset. Right? And so one thing we saw was that we could display the dataset, right? But we can also look inside. So what type is it? It is of this dataset type, which is defined in the tech.ml dataset library. And this type is a Clojure data type that happens to implement lots of Java interfaces and Clojure protocols. And in particular, it turns out that it is a map, right? So it can behave as a map, even though it is not the usual Clojure map you may be used to. And you may ask for the keys of it. And the keys, they are the column names, of course, right? Just to recall, this is our data set and the keys are the column names, right? And we can fetch a column by the key. Now, when we do that, we get a column data structure, which is yet another data type. One day you may be curious about it. The type of it is something called column, which is also defined in the tech.ml dataset library. But what we care about now is that this column has the type of the elements, which is indeed local date time. So we did get it right with the date time parsing. Great. So we'll continue now. And what we hope to do is to visualize the progress of the community. So, this is a time series, right? So to look into this time series of events, it might be useful to sort them by date and time. The way it is now is that actually it is reversed. The latest event, which is our coming conference in May, that's the first row of the dataset. So we want to reorder this. So we can do, let us maybe add ordering. Let us add this tablecloth order by call. We may order by the date time. Let us do that. Great. Now it begins where it should begin. That is probably the first event of the Clojure calendar feed ever. This, broadcast by practically the amazing practically. Maybe do you remember that event? Right. So that's one thing we can, do or with tablecloth. But now, we wish to look into it as a time series, and for that we may need to count events. So let us add a count. So we wish to add a column that will be running number, so we can maybe keep going with the previous structure we already had. So in my Emacs setup, I have this key binding to duplicate the previous piece of code. And now we will use add column. The way add column works is that you may name the column you're adding. Let us call it count. And then you write a function over the whole data set you have in hand, and you act on this whole data set and compute the column to be added. So this way, this functional way is very, very much suitable for this pipeline approach we're using. So now we wish to have a range of numbers over the row count of the data set. Right? So we did get this additional count column. Now we may visualize that. To do that, we will use another little piece of knowledge, which is table plot. Table plot is this plotting library that offers this so-called layered grammar of graphics approach that you may know about from famous libraries like ggplot. And we'll use the plotly API of table plot that generates Plotly plots. Plotly is this JavaScript library, and you see you can create those interactive plots with it. And the way we do it is by defining a layer of points, for example. And we specify the fields. You can find these details in the table plot documentation and in the node documentation. So the X value for us, let us recall our data set. The X value will be the date time. That's the X-axis. And the Y will be the count. Right? So now we get this scatter plot of points. And now we're learning something about the calendar feed. There is this gap that happened, and I'm not sure actually about the interpretation of this. Possibly, I think we did stop using it for some time. Maybe it is a technical detail. I'm not sure. And actually, it is an interesting historical question, but maybe for today, let us maybe not care about that and focus on the last couple of years. How can we focus on the last couple of years? To do that, we'll add a year column, right? So, oh yeah, maybe I forgot. I should have maybe separate this into two steps, just, for the storytelling. Let us first add the count column and then, plot series, right? This way, when we do things step by step, we're creating a useful tutorial where one can learn what we do step by step, right? So, right, we have these visualizations in our notebook. Let us now add the year column. To do that, we will use add column again. We add the year, and we are adding the year again as a function of the whole data set. And we wish to, somehow process the date time of our data set and turn it into a number, into a year. So we'll use another namespace, which is again part of Node. This is from the dtype-next library, which is this array programming library, which is in a way the foundation of a lot of what we do. So dtype-next has this nice namespace for date time processing. You can look it up in the dtype-next documentation, and we'll use that. So one function it has is long temporal field that computes a long, that is a number, out of each of these date time objects. And you see this function acts on a whole column or a whole array of values. So when we do that, let's go back to our clay view. When we do that, we get an additional year column. And now we can filter by year, right? So yeah, let us maybe filter by year. Here, keeping the last. So tablecloth offer select rows, and select rows can, act with a function that will be a predicate of a row. And in this case, it will check for each row if we fetch the year, whether it is at least 2023. Let us do that. And now we see we begin with 2023. And this is this amazing talk by Maurizio that did happen in the beginning of 2023. Do you remember that talk? Right? So now we have this subset we care about, and we can visualize again. Yeah, let's maybe visualize again. So again, we can do plotly layer point, x will be dt star, and y will be count. Now the story is simpler, right? But we wish to add, to see more details here, right? So let us do that. Let us, make the plot informative. So we can, for example, add the text to be the summary column. So now we can see what these meetings are about. So many events of so many different groups and communities in the Clojure community, right? So could we color the events by group? Right, we should maybe first recognize groups, certain Clojure groups. So to do that, maybe it will be easier to look into the URL of the events, where you can recognize these patterns like Los Angeles Clojure users group, right? So for example, we could add a column that will be the group. We add a column with a different way now, which is map columns. It is a different way to add columns in TableCloth. We add a column we'll call group. It will be computed from the URL. The URL column as a function of URL. Yeah, and maybe first, let us visualize our data set again so we can recall the details here. So our function of the URL will try to find a certain pattern, regular expression, which is, yeah, let us take the London Clojurians we see here in the first row. So it will be London Clojurians. And just, to be safe, let us do that with a lowercase URL, just in case there are some capital letters. So when we do that, we have a problem. Turns out that at some point we did have a nil URL. So, let us for now just select all the rows where the URL is non-nil. I think it was only one. Let us maybe not spend so much time with this question now. So right now we did get this group column, which is either London Clojurians or nil in other cases, because at the moment we're not even trying to recognize any of the other groups. Let us maybe add Los Angeles Clojure user group. So right, so now we have also these ones. So it is becoming a bit detailed, and yeah, and actually, since we already know a few of the other groups, we have the visual tools group and the data recur. All of these are Clojure groups, and the real world data and the Clojure LLM meetup groups and so on. So now we get a few of these cases. And now let us color by group. So again, we do plotly layer point, and what we'll add now is the color, and that is common in these layered grammar of graphics interfaces, that we can color our plot by a column. So we'll color by the group. Now we see all those different colors of the events, but this doesn't allow us to kind of see things so clearly because all the groups are mixed. Could we maybe have a separate time series for each of these groups? So let us do that. Time series group. Right. So again, maybe let us remove the plotting for now. And what we want actually is that this count column will be counting separately for each of the groups. So we'll remove the counting here and we'll first group by the column of the group. And when we group by, we get this grouped data set where we have actually a row per group, and inside the row we have a data set, a whole data set inside. So you see, for example, here 42 events in the last couple of years for London Clojurians. And now when we add or maybe let us maybe copy this previous computation of the count column, and we do that in the context of the group dataset, then the count is computed inside groups. That is typical to tablecloth. Tablecloth respects this idea of grouped datasets, and many of the functions, like add column, they act inside groups or in the context of a group dataset. After we do that, we can ungroup. So we'll not have a group data set. We kind of unpile everything again. And then what we get is the ungrouped data set where the count is actually counting inside each group. So here you see the London Clojurians with the count running, and then later on you see real world data with the count running and so on. So that's nice. And we can now visualize. So again, we will add our plotting, or maybe let us do it next time. So plotting the multiple series, and now we will just we just add our plotting call with no change at all. Now the count is per group, and you see the progress of these different groups. Like, the real world data, for example, is rather persistent in its growth, and some groups did have breaks and did come back and so on. A line would make it a bit more useful, right? So we could also have a layer of lines. And typically, we don't want to repeat ourselves, so we can add a base call of the Plotly API that will, define these parameters, and then the different layers will not have to add any of their own parameters, which is a shorter way to write this. So in a way, we did get our report now. We did get a visual view of the progress of different Clojure groups. And the purple one is the nil group, where we have more of these events. Let us maybe again add the summary. So we can add the text as the summary, and we may see that some of these purple events are actually so interesting, like the conference, which is coming in May, and so on, some of those special meetings. So that is where our report is ready, and we will now publish our report. So before we do that, let us talk again about Clay, the tool we've been using to visualize things. And you remember Clay is this data visualization and notebooking tool, one of a few tools that support the kindly standard. And Clay also allows us to create Quotum specifications. Quotum is this publishing system, which is used for notebooks and websites and blogs and books and slideshows and so on, and articles in many programming languages. It allows for this littered programming experience, which is cross-language. And Clay can create the Quotum markdown pages that can be rendered into those many different targets. To do that, you will need to install the Quoto command line interface in your machine, which is not so difficult. And now, since I already have it installed, I'll use the clay make Quoto HTML command and look into my clay browser view. And this takes a moment because it goes through Quoto, but now it is rendered differently with some different styling, and you can control the theme and the font and many details here. And that's how we typically publish our documentation of different projects. You also have another thing you may another way you can use Quoto, which is Quoto make namespace Quoto clay make namespace Quoto reveal.js that creates those slideshows. So this way you get a slideshow of our whole progress of of our data set. Oh, and now I see I should have, turned these into headings of uh, different paragraphs. So let's do that actually. And so we can add the heading sign. So yeah, now things, will be more friendly for a slideshow. Sorry for this little detail. So I have a key binding to re-render it as a slideshow. And then, just if you like this way, then you can get a slideshow of all the progress of different things we've been creating. Great. So let us render it the usual way again. And now we wish to make our report ready over the web. So for this, we will create a GitHub repo to hold our report. And so here we are at the Clojure organization. I'll create a new repo. We'll call it, it should be under Clojure. Node version 2 getting started. And it will be a public repo. Create it. And here I'll just have the usual GitHub way of beginning with a new repo, and should be ready now. Oh, sorry. We have our README, and let us maybe add some of our files. Now I'm using Emacs with Magit, which is the nice Emacs way to work with Git. So I'll add the initial analysis. And we also need to render the docs. And one thing which is typically useful when you publish things with Clay is a Clay configuration file. And so it is just an Eden file where you can add some details. And you can, see more elaborate examples, for example, of the Notch project itself. It has a more elaborate setup, and you can learn from these projects about and from the Clay documentation, of course, about what you may include in those Clay configurations. The part we care about is at least the remote repo setup that will allow us to link to the source. So in our case, the remote repo will be Notch version 2 getting started. And this way, when we render things, they will have a link to the source. So let us maybe render again using Quoto, and which takes a moment. And then at the bottom, you see you have this link to the source that should link to GitHub when you have the source over there. Should it already link? Oh no, why no? Because we haven't pushed it yet, right? So let us push our initial analysis to the repo. And then we try to open this link again. And, oh, right, because I have a typo. Makes sense, right? So getting started. And again, I render, and click this link. Should be the correct link to the source now. Yes, so we do link to the source. Right, so um, uh, when we render our code with our notebook with Clay, it creates this targets directory with everything we've created. And let us maybe add this target directory to our repo. Let's call it like render notebook and push it. But then we need to tell GitHub to actually view that. And, we go to the GitHub config and um, go to the pages part and need to tell it to use GitHub pages with the main branch and the docs directory, which was our target. And now when we save that, it invokes a GitHub action that will render our artifacts over GitHub pages and make them ready to be served over there. And that is where our journey in this tutorial ends. I wish to thank you for listening to this tutorial, and we really, really hope to hear your feedback and hear about what might make those tutorials useful for you. Different environments and tools and use cases and problem sets you may care about are other things we may create tutorials for to make Nodge and Cycloge more accessible for your needs. And let us chat. And so, yeah, our report is rendered over the web and we have our final plot over there. And I encourage you to follow the calendar feeds and coming events. And, we'll meet a lot in the coming days. So we have a lot to talk about together. Thank you for listening. Looking forward to hearing your feedback and see you on the next times.